Hi everyone and welcome again to this Python for Absolute Beginners course. So we're here on a new section of our course where we are going to start to work around with one of the most basic objects that we've learned so far, the Python string. From now on, in the next, I would say 4 to 5 sections, we are going to go into detail into the objects that we've learned so far. We already have here a good grasp on what are variables, comparisons, operators, so it will be easier for us to work around with the objects. We are going to go into more detail into the objects until we have a good grasp on them and until we are able to practice with these objects that are the most basic components that you can stick together to build a Python program. That's our aim right now for the next 4 or 5 sections, till the part where we write our own coding, okay? Of course, this will all be done with our practical exercises and our case study where we are building our own RPG game, okay? So we'll continue always with the same mindset until we are able to build our own game using Python code, or at least components, of course, of our own game. Okay, so let's start. We are going to 3 Python strings, and we are going to start with the overall introduction notebook that we have there. Let me go for my working notebook and delete everything that we've talked about in the past sections. Here where we spoke about our operators, that was the last part before the exercises, so that's it. Let me go for Python strings. Okay, so we had like a 6 or 7 minute introduction to Python strings. Here we are going to detail them a bit better, understand a bit of the methods that we can work around with them, and understand how they are different from other types of objects. So again, how do we know that we are working with a string? Calling type on something, for example, ABC should return str. If it returns str, it's a string. We can work around with it as if we are dealing with text. So an important thing is that you can define strings with single quotes or with double quotes. Okay, so either the single quotes, double quotes, this is more of a personal preference. You can define them as you want. You'll have both of them. If I call type on both of them here, let me also prove that. Type, it's an str, the type of this one. So as you notice, both are interpreted as string. How is the computer storing this? So the computer is storing all these elements using bytes. Okay, so zeros and ones, it's storing all these letters under the hood as a representation, as a binary representation. We are not going to go into binary code here. Don't worry, that's a bit low level in terms of Python. Python is here to act as an interface between that binary representation and how we interact with the computer. But even so, I think this is curious for us to see. Let's see how a computer is storing, for example, one variable that I'm going to call here a variable with Europe. So the word Europe. How is the computer storing this? I'm going to pick up the code that we have here on the strings overall. I'm going to copy this one. We don't need to go around this code right now. Don't worry about it. We just need to put here, instead of our string, we can put variable, okay? Or you can call it our string here. That's all the same. So let's see. Here is the binary representation. And this is the binary representation of this word Europe. Now, one of the most important things, remember when we compared, for example, A in a uppercase letter versus A in a lowercase letter, what the computer does is comparing the binary representation of those letters and check if they are equal or not. They are not equal because the binary representation of that single letter is different, the A in lowercase with the A in uppercase. That is how the computer is understanding a language and understanding text. For example, if I go for, instead of using Europe, I'll work with Europe a bit later, I'll use this A and I have this single binary representation. As you can see, it's just this set of zeros and ones. You can ignore this 0B right here. So if we have this binary representation, and I'm going to save it, I can even save it in a variable. I'll do bin rep A. Okay, oh, whoops, forgot the assignment. And if I have another variable, which is the A in uppercase, and I check the binary representation of this A in uppercase, I'm going to go here, variable, and I can put A1. Just to be a bit more clear, I'm going to put variable upper. And I'm going to call this variable upper right here and check the binary representation. So this binary representation, here it is, the binary representation of the A in uppercase. Let me pick up the binary representation of A in lowercase. Okay, this should be familiar to you right now, what I'm doing here. Of course, I'm not going to go into too many details right here on this code and this function bin. You don't need to know this actually. What's important is that you understand that this is a function that's returning something. It's returning a string, which is the binary representation, and I'm saving it in a variable. So this should ring a bell somewhere in your mind, because we've already done this, okay, with other functions. If I'm not using this bin, I may use an ABS function. I may use another type of function that's returning something, a type function, for example. It's returning me something, and I can save it immediately in a variable. This is a key concept here in Python. Now let me see the binary representation of A. Notice that there's a single number that changes in these two binary representations. So that's why A uppercase and A lowercase are not the same for the computer. As Python is case sensitive, means it's sensitive to if the letter is in uppercase or in lowercase, it has different representations of this character alone. Okay, I actually don't know how lowercase, how programming languages that are not case sensitive work under the hood, but I'm not sure if they save the representation as different and they have some kind of mapping on a higher level. I'm not going to risk on that. But here, what's important is that you understand that A in lowercase, A in uppercase are different because they have different binary representations. As you notice, longer words, I can go here and write, let me now ditch all of this, it will be easier. Let me go here for Europe, and if I go here and write the variable Europe again, the longer the word, the larger the binary representation, the more space it takes on your computer to store this word. Okay, if I have even a larger sentence, I'll have a really big binary representation. So this binary representation is just a concatenation of the letters that we have right here. Okay. Also, numbers also have this binary representation. Numbers enclosed in single quotes. If I try to do numbers, now the numbers are stored a bit different, okay? So this representation that I'm doing with this encoding is just relevant for strings, okay? Just understand everything that's enclosed in strings has some type of binary representation that we are storing, and that's why under the hood they are different, okay? The computer considers it different. Although for us, A and A, well, we know that one is lowercase and the other is uppercase, but the sound is the same. They represent mostly the same in a sentence. For the computer, that's not the case. So A lowercase, different than uppercase.